Now here's a very complicated problem. Let's say I'm selling eggs, Weggs eggs. Probability that you find a cracked egg in a box of 12 is 0.1. That means no cracks is 0.9. We'll use this information later. We're looking in 12 at a time, 12 eggs in a box. So what we do is we take the first box. If there's no cracks, we've passed. So that's good. If there's 2 or more cracked, we fail. If there's only 1 cracked though, we test the next box. If the next box has any cracks in it, so let's put this down here. It fails. So we've got quite a complex problem to work out with different probabilities, but this is what could happen. Here's another way of drawing the diagram to think about this. First of all, it could pass, and then it's passed anyway, so it just moves on. Then you could have it fails completely. Then the other option is it kind of fails, but then it passes, which would allow us through. Or it fails, the first box, and the second box fails on the tighter criteria of no eggs cracked at all. So what we're looking at here is the first one. First probability that's useful to us to make it pass would be you've got all eggs passing, which is 12, choose 12, all of those pass at 0.9, and that means the failure rate is 0. That's one probability we have to work out. Now if we're looking at the whole batch passing, we're not interested in the failures, we're just looking at where we do have some passing. So we've got 2 distinct probabilities to work out, as well as this first one that's very easy. So the fail that we're looking at here is only one of them cracked. So one of them cracked would be 12, choose 1, so that's one of them cracked, 11 of them okay. Now for this to pass, we now have to have all eggs being fine, which means every single egg passes, which would be 12. We could say that none are cracked in this case. 12 choose nothing, so that's 0.1 to the nothing and 0.9 to the 12. Notice I switch my notation a little bit from top and the bottom. That doesn't matter as long as I remember that which one of these is cracked and not cracked, or pass and failing. So at this point I've got 2 things to work out: the probability of it passing first time and the probability of it passing after a first failure of 1 cracked egg, and that's what we'll calculate now. Before I pull out the result, here's a different diagram showing you what's happening. Passing, test again, or failing. So at this point, if I was to continue that tree, that would be just multiplied by a probability of 1, because it's already passed. So would the fail, because we're not interested in that anymore. So all we're looking at is this branch of the tree with this branch of the tree. So let's go back to the numbers. So if my calculations are correct, we should have the probability of it just passing straight away is 0.2824, etc. The chance it failing for retest and then passing is 0.1063552574. Adding those together, the probability of the batch passing is 0.38837847939. Again, we'd normally put that to 3 significant figures, so 0.389. What that would tell me is that I'm going to be I'm only passing approximately 0.4 or 40% of the eggs. That means I'm failing with lots of them, which tells me my egg production system is going to lose me a lot of money.